Find the moment at point A in Newton meters. In this problem, an L-shaped figure of given dimensions is connected to a foundation at point A with a fixed connection. At point B, a force of 400 newtons is applied at an angle of 70 degrees to the horizontal. To begin solving for the moment at point A, we first check to make sure point A can sustain a moment, which it can, because it is a fixed connection. A fixed connection involves three reactions: a horizontal force, a vertical force, and a moment. Another common connection is a pin connection, which supports two reactions, a horizontal force and a vertical force. And one other common connection is a roller connection, which only supports a reaction force normal to the adjoining plane. For simplicity, the vertical forces are labeled with a subscript y, corresponding to the y-axis, and the horizontal forces are labeled with a subscript x, corresponding to the x-axis. The problem asks to solve for the moment at point A, which can be calculated by summing the moments around point A, setting the value equal to 0, and then solving for the moment at point A. The moment created by a force equals the orthogonal component of the force times the distance between the point where the moment is taken and the point where the force is applied. For this problem, the 400 Newton force is divided into its horizontal and vertical components, F sub bx and F sub by. F sub bx equals the force at B times the cosine of the angle the force makes with the x-axis, theta. F sub by equals the force at B times the cosine of the angle the force makes with the y-axis, phi. Plugging in the force, F sub B, in the angles, theta and phi, the force in the x direction equals 136.8 newtons, and the force in the y direction equals 375.9 newtons. If we define the counterclockwise direction around point A as a positive moment, and the clockwise direction around point A as a negative moment, then the sum of the moments equals the moment at point A minus the horizontal force, F sub bx, times the distance to the horizontal force, dy, minus the vertical force, F sub by, times the distance to the vertical force, dx. Setting the equation equal to 0, solving for the moment at point A, and plugging in the known forces and distances, the moment at point A equals 213.7 Newton meters. When reviewing the possible solutions, the answer is D.